So we had ended here, I believe, right? In the last class, we were discussing uh, automated flow lines. Yes, we started the concept of automated flow lines. So what we saw that, uh, as the name suggests, flow line, you have to have a what do you call flow of uh, work pieces. So basically, the workstations are so connected that they are linked together, right? That's that's an important thing to remember, that they are linked together by work handling devices that transfer parts between the stations. So that's how you form a line, right? Flow line. So each machine is dedicated for a specific task, as I said, specialized functions, right? So they have to be linked by work handling devices, an important element. uh, it occurs automatically, transfer occurs automatically, and the works, right, specialized functions, right? And sequentially, they perform sequentially, one station to the next. There is even possibility to incorporate buffer zones also, right? Either at single location or between every other workstation, as we had seen, that it could be any between any two workstation, or it could there could be a dedicated buffer storage zone. And also possible to include inspection stations, manual stations also possible, wherever it is very difficult to automate, right? So I'll just take you quickly. Reduction of labor costs, production rates increase. That's one of the major benefit that you get. High production rate, specialization of operation, right? All these objectives we saw. So if there are any doubts, you can ask, because the unit is, you can say, totally relies on this automated flow lines, and we have what do you call one problem as well, analysis, I think. Yes, analysis of automated flow lines is in this unit only. So you will be able to solve that problem and you understand what is happening. Okay. So you have the configurations inline type, right? You have them all inline. Still, like, this was your example of 20 station inline configuration. But other thing is, even though if they are not forming a straight line, but we still call it segmented inline. Okay. So, and this could be because of, as I said, factory space limitations, right? There could be limitations because of space, or orientation of the machines also, right? So you can have it in an L shape, but that will still be called an inline. Okay. Because there's no machine, there's nothing in between these two, right? So they are forming, they're going, the parts are going one after the other, I mean, one machine to the next. So it still qualifies as straight line. And then you have another rectangular and U shaped, right? This is which we were discussing, that the advantage is you have this, yes, we saw that example, right, of that pallet washing station. This is basically your what do you call ladder type itself, not inline. Because uh, if they are connected, then yes, it's a rectangular one, otherwise it's an inline. Okay, because it's not very clear, that's what. And other thing is your U-shaped configuration, right? So it depends on the factory space limitations, uh, the orientation of the machines also, as I said. So, and here you see this processing, PROCOAUT. What does that indicate? I told you yesterday, right? PROC, that's processing, like basically a processing station. And AUT indicates it is automated. So, but it could be an assembly station also. Okay, we are discussing configurations of automated flow lines. There could be this is applied to both processing, not just processing and assembly, but also inspection also, right? Or even sorting stations. Okay, that the stations where you what do you call, classify those workpieces, okay, so that you can send one type of workpiece to one station, other to another, okay, like that. You could have a sorting station in between also. So what we are trying to discuss is the configuration of it. Rectangular shaped, U shaped, it could be either processing or assembly or sorting or inspection, etc. Clear, right? All these four types, right? Even you have this rotary type here. One more. Work parts are indexed around a circular table or dial. Workstations are stationary and usually located around the, you see, outside, around the outside periphery of this dial, right? We had seen this same example, this same image in automated assembly, right? When I was trying to explain automated assembly, I just showed you the example of one configuration, which was this. Okay, so that's what uh, a rotary type of configuration looks like. Okay, so this table will move, right, and every part will be taken. You have these pallets, right, and the work parts will be placed on that pallet, and this table will move. It will take the parts to every other uh, processing or every other workstation, let's call it, right, generally. So another thing to point out is that you have to have this what do you call, synchronization. You see, if this machine takes 2 minutes of time and this machine takes 3 minutes of time, and the work table that you have set, right, it it has to move with a constant what do you call, angular velocity, right, has to move, or that steps that you're taking has to be synchronous. Like for every 10 seconds this table will move, okay, this much of angle. You're trying to get what I'm trying to say. Let me take a different color, or maybe let's take this color. You see, so for every turn the table has to move this much angle, right, it has to take this angle. So if they are not having same processing time, then you cannot implement this kind of system, rotary system. Isn't it common sense, right, that all of them have to have the same processing time? Like each one of them will do a certain task, which has to be it should be very, they should be having a processing time very close, right? It shouldn't be like one machine is having a higher processing time, so because of that you have to, the other machines would be idle, right, non-productive time. So that's what you have to make sure when you design this kind of system, rotary type of system. Parts ride on the rotating table and are registered or positioned in turn at each station for its processing or assembly operation, right? So the parts is what will go. I mean, the table will move and the parts are being taken to every other workstation. That's what is meant, often referred to as an indexing machine or dial index machine. So indexing machine, in the sense, you have this indexing mechanism also, that to be able to achieve exactly that kind of, because you see, if that spindle is not able, if the work part is not able to go to the exact center of the spindle, okay, then that becomes a problem, right? Especially for machining, the positioning also depends on this indexing mechanism, right? That's a very important point, that uh, the mechanism which is used to rotate this table has to be very precise, so that this processing whichever is to be done has to be the performance of that will depend on this mechanism, right? So indexing machine or in dial index machine, you have these mechanisms, I believe, in uh, machine tools. I don't know what subject the subject of the name is in your curriculum, but when you're discussing machine tools, you'll discuss the type of mechanisms, and we do have certain mechanisms, I believe, coming up, right? Yes, so that will give you the idea of how this index is done, indexing of this is done. Okay, clear? Rotary type. Okay, so yes, that's your rotary type, and that's how it looks like. Okay, your rotary type of configuration. When it comes to method of work part transport, you have these transfer mechanisms must not only move partially completed work parts between adjacent, it's also, yes, the responsibility, it is also responsible for orienting and locating the parts also. The transfer mechanisms which you are using, discussing what are the methods of this work part transport. Okay, so it should also be able to orient and locate the parts in the correct position. But before that, let me show you a video, because we have discussed, yes, we have discussed, yes. So let us have a look at the automated flow line, that is sheet metal, I believe, because videos are what gives you the idea, right? It will give you a clear picture. Okay, let me share the screen. Able to see? I think I did not press share sound. Yes. Now please confirm if you are able to hear the audio also and the video. Able to see both the video and the and hear the audio? Yes. Yes. Okay. So let's look at this video. Okay. You see how big these workstations are, right? Each, I showed you that in the PPT, right? You have the those workstations in line. Okay, one after the other. You see how big those systems are. Just one workstation, which is responsible for one specialized function that it does. So in here we are seeing what do you call this sheet metal processing, right? We'll see how that is able to do. But each one of these is responsible for a specialized function, okay, to give a certain shape, or to maybe blanket, okay, like take cut it from a blank, trim it, okay, from a big blank, it will trim. So each one of that is responsible for one particular uh, specialized function. So you see, when they design it, they solely take that specialized function into consideration and design it, isn't it? And now you tell me if there are any changes in that function that they are going to do, how difficult it is to make the changes, especially when you have got a workstation of this size, right? That's why we were saying that in rigid automation, basically this is an example of rigid automation, right? Because as I told you, automated flow lines, they are used for high production. So to be able to do that, you have to have a dedicated machine, and in here is your dedicated machine. So, and they are, each one of them is responsible for a specialized function. So that's why we say that it's very difficult to make changes, to incorporate the product design changes, right? It costs a lot more than we think. So you see, it starts from here. Okay, he'll show you. He gave you the tour of that total flow line, okay, automated flow line. Now he's explaining you that how those sheet metals are being formed now, how are they being given the shape. Okay, you see the very next machine. This is that's what you all automated material handling, right? They are picking uh, one robo was responsible for taking it and keeping it here, and another one is responsible for taking it from here to the next workstation, and there he's giving the shape. Then the first machine in our automated flow line, you see, if you observe closely in that, you see that shape. So that's your first specialized function, you can say. So when we are saying it is also responsible for locating and orienting, you mean to say it is responsible for keeping it at the exact location, right? That is also the responsibility of a material handling system, right? As I told you, not just handling in the sense it should be able to orient it also, it should be able to store also. Storage is also one aspect of automated material handling. So we can even see those aspects, right? Even though we are discussing automated flow lines, we are also discussing the material handling also. Okay, so observe that. So now same thing, that from first workstation, this is keeping it to the next workstation. That's your material handling system. So, and that is performing another specialized function, right? Okay, I think there was a problem with the network. Okay, let me share. So, as I told you, very less workers are required, and they'll be in supervision, right? There will be supervising, they'll be monitoring it. So, all these, you see, these, uh, after cutting that blank, the trimmed parts, okay, the leftover parts, those those are there, right? And if you leave it unattended, should I? Yes. Now this is clear, right? So if you leave it unattended, those trimmed parts, okay, which are what do you call, which are unwanted parts basically, right? When they come out, and they'll be, let me show you. So if that comes in between these material handling system, right? And so workers are responsible for ensuring that it doesn't happen, okay? So that sense of monitoring, when we say workers are monitoring and supervising, this kind of monitoring, and even any malfunctions in the machine, etc., okay, rest all will be taken care by that system, okay? Okay, don't just observe the material handling, also observe the different devices, right, that you can relate to, that we saw in the last unit, okay? So you see the product has changed now, right? Earlier we were having a different product. So you just change the fixture and that die, right? The die and the punch basically, and you can have a new product, right? So they are able to accommodate changes, but not changes of what do you call significant changes, no. Because you see, earlier the product was sheet metal, right? And it was not having much what do you call uh, thickness, depth, right? If you observe the previous product, you see that die, if you can see the die setup, you see that die setup, if you can change, and also it depends on the constraints of the machine. For example, certain materials would require a very high punching force, right? So keeping those limitations, if you can design, right, a system that you think that will be able to process a significant amount of materials, okay, so that's why it becomes what do you call general purpose equipment, right? And hence costs you a lot. We discussed these points, right, in your last unit. So that, and what else is to be observed? Whatever is it that you can observe, right? Put it in the chat box, or okay, unmute. You see, those are the pallets, right? Wooden pallets. You see, also observe this forklift with the material handling, right? Between what do you call, not between the stations, but to take it from one department to the other, is using this forklift, which is obviously, as you can see, operated by a human. But when it comes to that what do you call flexible manufacturing system, even this is carried, I mean, taken care by the automated guided vehicle, right? We discussed in automated material handling last unit, right? So those places, like even these functions, will be taken care by AGVs when we talk about completely automating it. Okay, you will have these lines for them to follow, for the AGVs to follow, right? And make sure that they don't collide with other AGVs, automated guided vehicles. Okay, so you can say this is not completely automated, but the flow line, this automated flow line, you can say this is completely automated, isn't it? Can we call it, or do you have any doubts? Okay, so that was your, and what was that automated flow line for? It was basically a press line. Okay, as was mentioned in the video, it was a press line, right, for sheet metals. Okay, other thing, any other thing that we can see with respect to this topic? Yes, this is another short video. Let's look at this. How much is the time for the meeting? Okay, less than a minute. So it is only sensible if I